Question 6. A factory uses a machine to produce electrical sockets. The manager carries out a survey to investigate the probability of the machine producing a defective socket. The relative frequency of defective sockets produced was calculated after testing a total of 1,000, 2,000, 3,000, 4,000 and 5,000 sockets, and the results are plotted on the graph below. As we know, the relative frequency of something is how often it happens divided by all the outcomes, and it's a form of experimental probability. Part A asks us how many of the first 3,000 sockets tested were defective. So if we look along the x-axis to find the number of sockets tested, we can see that's 3,000. We have a look and see that it was there. The relative frequency taken off the y-axis, we can see is 0.05. Oh, sorry, yeah, 0.05. If we multiply that by the number of sockets tested, 3,000, we can see that of the first 3,000 tested, 150 were defective. If we go on to part B of this question, it asks us to write down the best estimate for the probability that one socket selected at random will be defective. You must give a reason for your choice. Well, if we go back to our graph, as I said, relative frequency is how often something happens divided by all the outcomes. The more you test, the better the estimate of the probability will be. So I'm going to look straight at the 5,000 figure on our x-axis to see what the relative frequency was when 5,000 was tested. And if I look carefully, I can see it's just about there, and that's about 0.048. I'm going to write that as my answer, 0.048. And the reason I would give for my choice would be that experimental probability is most accurate when a large number of items have been tested in this case. So if I write greatest number of outcomes, greatest number of sockets tested, that'll give an indication to the examiner that I looked at the 5,000.